Welcome to NSOMASA NMIMS podcast, where we bring you the exciting conversations with thought leaders from various fields. I am K.S. Madhavarao, Professor of Statistics from the Department of Statistics, NSOMASA. Let us welcome our guest, Professor Dr. Somnath Datta, who currently works as a professor in the Department of Biostatistics, University of Florida, Gainesville, Florida, USA, who has been interviewed by students Arjun Seth and Ishita Daluka.
Hello and welcome to this exciting and informative podcast where we, the students of ICS conference organized by NSOMASA NMIMS, are going deep dive into statistics and bioinformatics to provide some valuable insights and inspire the youth. I am Ishita Dhanuka along with my co-host Arjun Seth. We have with us today Honorable Professor Dr. Somnath Datta.
Thank you for having me. It's a pleasure to talk to you.
Same here, sir. So we'd just like to give a short introduction about our guest. Dr. Somnath Datta is a distinguished statistician and professor at the University of Florida, USA. He received his B.Stat in statistics and M.Stat in mathematical statistics and probability from the Indian Statistical Institute, Kolkata in 1983 and 1985 respectively, along with his Ph.D. in statistics and probability from the Michigan State University in 1988. Dr. Datta has made significant contributions in the areas of survival analysis, mixed models, Bayesian analysis, and bioinformatics. He has published over 160 research papers in numerous leading international journals and has co-authored 2 books, namely Statistical Analysis of Microbiome Data and Statistical Analysis of Next-Generation Sequencing Data from Springer. Dr. Datta has served as an associate editor for various leading statistical journals, including the Journal of the American Statistical Association, and co-editor for the Sankhya at the Indian Statistical Institute. He has also been elected as a fellow of the American Statistical Association and the Institute of Mathematical Statistics. Dr. Datta has received numerous awards and honors for his contribution to the field of statistics, including multiple CDC ATSTR awards, along with the President's Distinguished Faculty Award in Research for Career Achievement, University of Leuven. Dr. Datta is a highly respected and sought-after speaker, having given numerous invited talks at conferences and universities worldwide. He has also done various short visits at several leading institutions, including the National University of Singapore, University of Leuven, USA, and University of Malaya, Malaysia. Currently, Dr. Datta serves as a professor of biostatistics at the University of Florida under the Preeminence Initiative. We are honored to have you here today, Dr. Datta. Thank you for joining us.
You're most welcome.
So, starting with the first question, what was your infusing moment in your life that inspired you to study statistics, followed by biostatistics in your later lives?
Okay, I will try to keep my answer short, but here is the truth. I actually went to IIT after passing my 12th grade. As you know, coming from a middle class background, IIT was a dream career for me in academics. So I went to IIT Kharagpur and tried to study mechanical engineering. And at that time, after 2 weeks, the result came out that I've been selected for pursuing undergraduate at Indian Statistical Institute as well. So I thought I will just go and try it out. I really didn't know exactly what statistics is besides, an overall vague idea, not detailed. But I was really, if I have to give somebody credit who changed my mind, it will be a professor who since passed away, late Professor Shomesh Bakshi. He gave such an inspiring lecture on probability theory. I thought this is totally cool, and I decided, okay, I'm going to stay here and I'm not going back. So basically that was the changing moment for me, why I studied statistics. And then after that, it was a pretty straightforward career for me. I did my undergraduate degree and master's degree from ISI. I went to Michigan State, and I was very well prepared already. I could finish my Ph.D. in 3 years. And I joined University of Georgia as an assistant professor in the Department of Statistics. I stayed there for 17 years. So I'm also answering your biostatistics. The move to biostatistics happened essentially due to two things. One is for family reasons. I lived in Atlanta after about 10 years of starting my career. And by then I met someone, my good friend now, Glenn Satin, who was working in biostatistics because he was working at CDC. So with that connection and interaction, I became interested in applying my techniques to biological data, And another reason is I also felt by then very strongly that it's better that I derive, even though my motivation, from problems which are practical in nature, because after all, statistics, the way originally it was created, came from application side. If you know, R.A. Fisher did it for genetics, then many of the design of experiments which we study in textbooks, they came from field trials. And after that, of course, and there was a need for theory, and I have done enough theory in my first 15 years. But I felt after that it's better that I move into applications. So all my methods came from applications.
So the next question is, as a statistician working in the field of biology, can you discuss the specific challenges and opportunities you face when analyzing biological data? How do you envision statistical methods evolving in the future with the increasing availability of big data in the biological sciences? And what role do you see for the advancement of machine learning in this context?
Yes, that's a very good question. So frankly, the challenges for me was to learn biology. I did not take biology as a subject during as you know, in Indian system, your fate is sealed right from the college days. So I decided that there's no way I'm going to study medicine, and I didn't take biology. I was more into, math and chemistry and physics. But all on a sudden, this is the decade of biological sciences. There are so many exciting things happening through genomics, genetics, and also more to genomics. I did mostly genomics, microarrays were coming up. So that created a platform where new statistical techniques could have been done to analyze those data. So this is how I jumped into that field. But then once you find something, you don't know if it makes sense. So I had to learn fair amount of biology and a little bit of biochemistry also to see what I'm finding, whether they make sense. Okay, so that's the challenge. We have to now learn enough biology and enough computer science also. Just like they are learning our act, they are getting better in learning some of the Bayesian techniques and so on. So we also have to learn some of the other disciplines. Yeah. But I feel like we can really, I think your question had another part about machine learning. So machine learning comes as a natural extension of some of our multivariate statistical techniques. In fact, one of the most celebrated machine learning techniques, in fact, I actually took part in a classification conference competition in the Netherlands where to analyze data. And there are people from all sorts of disciplines. So that was fascinating because there is certain joy. It's like instant gratification if you can predict a mystery sample and then they reveal it and you can see how you did it, Yes. So, and the technique that I use is called random forest. And random forest has become very popular. A lot of people think computer scientists derived it. It's not true. Random forest was created by Leo Breiman, who was a first-rate statistician from I'm getting confused now. Yes, I think from Berkeley. Okay, so a lot of statisticians actually developed these techniques. Okay, and the reason I say that, there are obviously great applications of this, and I myself have done a lot of other extensions of machine learning algorithms.
That's good to hear. So, as a professor of statistics, you have mentored many students over the years. Can you share any particularly memorable or impactful memory experience you have had, and how have these shaped your own approach to teaching and research?
Yes, this is a good question. Again, I don't know where to begin because I don't know. You probably had a quick, recent look at my CV. I think my PhD student count is probably around 25 or something right now. I'm not really sure. Anyway, so just this morning, somebody sent me a posting on Facebook. Okay, apparently my student is presenting at INAR, and somebody actually took a picture of that and sent it to me. So all these are very gratifying to see. I sort of knew, but I didn't keep track that he was at INAR presenting a poster that, of course, was part of his PhD. Yes, so if you ask for a specific moment that is hard, there are many students, each of them are special in their own way, but there are some who are more productive than others. But over the years, how it shaped my teaching, I try to become more, I am not perfect. I lose my temper sometimes, but I've become a lot better. Let me tell you that. Yeah. And I can understand how they are learning. I think I have become a lot more patient and so on and so forth. Yeah.
Thank you so much for that, sir.
Yeah.
So your work has involved applying statistical methods to address questions in the areas of bioinformatics. How do you approach developing statistical models for such complex systems? And what have been some of the most surprising or unexpected findings that have resulted from these analyses?
Yes, so that's I need to think about the unexpected part, but basically, what I try to do is to see what I can do to contribute rather than learning. Bioinformatics is a complex science. Okay, you need expertise from different disciplines. So computer scientists, for example, they are good in certain things. They can really do excellent coding. They can produce things which are faster. And then there are mathematicians who are good in mathematical modeling. So I try to approach it from what I can do, what is my expertise. So I produce techniques which are going to be tools, okay, for biologists and medical researchers in general. And these tools are based on my own understanding of statistical properties of a methodology. So they should have good statistical properties. So I have created in particular tools for clustering, and that is one of the highly cited papers. It has been really cited close to 800 times now. And of course, many more downloads. At that time, I was not sure it will become so popular that you asked me what was the most surprising. That is one of the surprising tools. And it goes beyond bioinformatics to see that people could use this to make some sort of statistically rigorous way of finding groups in data, as opposed to do something which is faster, right? So it depends on your own background. Right. So I always try to find problems where I feel it has a statistical solution.
So, your work has also involved collaboration with researchers in a variety of fields, including biology, medicine, and engineering. How do you approach interdisciplinary collaborations, and what have been some of your most challenging or rewarding aspects of the partnership?
Yes, that's also a very good question, and it makes me think. Sometimes, actually, some of the work come naturally. As a biostatistician, I am supposed to, meaning, that's a requirement essentially of devoting certain percentage of my time to help all the other researchers. Not everybody, but, generally researchers within the university. And so I have some structured work. For example, I work with people in VA. These are people who may get injured in war of some kind, and they develop certain types of conditions, and then there are hospitals, and there are researchers who are looking at the effect of certain types of rehabilitation therapies on these people. So for somehow during my natural course, I have been interacting with this sort of people, this sort of researchers, even in Louisville. So I have picked up on that expertise. It happened in a natural way. It's not like, okay, here I go to the shop and I have the flexibility of working with, okay, I can pick cancer versus, kidney and this and that. Like, it's not like that. It's whatever comes your way. It's like any other life experiences. At least that's what it happened with me. And in terms of engineering, that also, there was a unique opportunity in Louisville. And if I may say so, I had a neighbor who was also an Indian professor from this region, actually, not from here, your neighboring state. So maybe that had something to do. We started talking because I first met him in a social way, and then we started talking. And then he is the one who had the dynamism of writing a collaborative proposal to NSF. And this has to do with using statistics to predict certain properties of materials. So in materials, they can artificially create, put compounds and certain things together to create a new product, okay, which could be an alloy, it could be a compound. And what I did is I said, okay, very simplistic. It's basically some sort of regression analysis to predict. And then may be completely wrong. It may be okay, but it doesn't cost us much. If they have to, just imagine the alternative is if they have to really manufacture all these different permutation combination of elements and products, it will take forever and it will cost thousands, billions of dollars. So this is cheap. So once I have a reasonable library, I can build models. So that became very, very well received. It also got funding from the NSF. So that was my experience with working with the engineers. Well, the greatest challenge with working with a person in another field is to learn how to communicate. That is the hardest part. Some of them, now it should come from both ways. In fact, there are in good departments, especially in medical sciences, there are courses, there are trainings. They need to know when you go and see a statistician or biostatistician, what kind of questions to ask him. They need to understand their limitation, what a statisticians can do. If they don't understand that, then they will not really get much. At the same time, I also need to be very patient because I may speak a language which they don't understand. I need to really be patient and see what they are trying to tell me, if I can translate it in a language that I am comfortable. Because they will not tell you, okay, here is a regression model, or this is the value of this. Even to give a sample size calculation, this is something they know. You can go and ask a statistician to say, okay, how many samples should I collect? It's a very easy question, but to solve that question properly, you need to collect a lot of information. Oftentimes they don't have that. So but it's your job to try to find out how much they know and try to then do your best guess based on that. Yeah, so I think these are examples. So communication, be patient, try to learn their language. Also, if you are working in certain areas, it's a good idea to also learn from their subject papers. So for example, I have worked in dental data. So I have I had to pick up some books even to see the structure of teeth, some of the languages, like what are the names of the different positions and so on.
Oh, that was great. Thank you, sir. So, so having traveled to over 100 countries, you have undoubtedly encountered a wide range of cultures and ways of life. How has this global outlook influenced your research and your approach to problem solving in your field?
I never thought about how it helped me problem solving, but it might have. I probably needed a lot of this training in order to become, increase my patience. I travel because I like to, I am interested in learning culture, history, and philosophically speaking, why we are here, right? That's the ultimate truth. The Brahma, like everybody through religion is trying to, solve that. Although I am not religious in a traditional sense, I do feel the existence of somebody, a greater force. And so these are the reasons I travel. And definitely it has increased my overall mental health. Okay, so that's directly related to how I can solve my problem. So if you sit down, you'll just go nuts, right? Not travel anywhere. So I advise everybody to travel as much as possible. Yeah.
That's a great advice. So, Nilkamal School of Mathematics, Applied Statistics and Analytics, NSOMASA, offers two master programs, namely M.Sc Statistics and Data Science and M.Sc Applied Statistics and Analytics. They also offer 3 undergraduate programs as Applied Statistics and Analytics, Data Science and Artificial Intelligence. Did you have any opportunity to look into the programming structure and reflect on their suitability in terms of international benchmarking, imparting graduate abilities, industry preparedness and placements?
Frankly speaking, I have not had, but maybe in the future I would like to, if they formally ask me, I'll be happy to give my opinion.
Sir, a final question. Did you ever know about any of the core faculty in the Department of Statistics in NSOMASA? If yes, how well do you know them, their research interests and publications? And if not, do you have any opinion on the broad profile background of the core faculty and their research areas of interest?
I knew Dr. Rao. He's the only one I had known before. For 2 reasons. Number one, I got to know him through previous conferences. In fact, when he was in Botswana, he was a host of a conference that got organized by Professor Bimal Sinha, and I was one of the invited speakers. So naturally, I did know what he was working on. So clearly, I know of his research. As far as the rest of the faculty, I didn't know them before, but that's not surprising. There are so many people coming up, and now I know some of them, what they are doing, especially the younger ones. It's like, yeah, the one issue, I don't know if it is appropriate for me to say, it looks like they are teaching a lot. So that's challenging for them to continue doing their research.
Thank you so much, sir, for your valuable time and patience. With this, we come to an end of the podcast session. Thank you all for tuning in. And we would also like to express our gratitude to the platform that ICS 2023 and NMIMS has given us. Thank you so much.
Thank you all. You have an awesome young team.
Thank you, sir.